Hi, welcome to my class. Today I would like to discuss about the second part of the complete solution of KAGGLE, PIMA, Indian diabetes dataset, how to achieve 92% accuracy. Now, if you missed my first presentation, then please go through it. What I want to say that a simple scatter plot could open the relations between two variables, and if you can understand the relationship very well, then you can increase this efficiency of any classifier. Now, what is the root of the decision tree? So it is a non-parametric method. So it will divide the feature space with the horizontal line and the vertical line. It is known as the decision boundary. So in case of the decision tree, we are having rectangular decision boundary in 2D space if you consider. When you are considering three-dimensional space, you will get this hypercube. Now, I repeat this line, that is divide and conquer. So decision tree, it is basically top down, repetitive, or the recursive programming approach to divide the feature space one after another to enhance this accuracy. Now, let us come to our discussion. So this is the scatter plot. I'm using plotly. I'm considering these two variable here, that is the glucose and BMI. And if you check here, you are getting these two classes, that is the two output variables. One is black, another is blue in color. So black means no sign of diabetes. And if you get the blue, it is a sign of diabetes. Okay. So if you check this one, so I will use the same method or the same approach. What I will do, I will divide the feature space, this feature space, with the horizontal line and the vertical lines, and I will get a small region. And for this region, I will analyze and I will add a rule. So let's see what I am doing. So I am considering, in this case, the above scattered diagram. If BMI is less than equal to 30, glucose less than equal to 105, so you will get only black points. So in this case, you can say, let us consider this rule is N7. So data frame, all rows N7, this is equal to 1. So data frame locations, I am filtering with the condition, that is if glucose less than equal to 105 and BMI less than equal to 30, so you will get N7, and the corresponding column value, that is output variable value, should be equal to 1, because sorry, it is equal to 0 because it belongs to class 0. See, outcome is 0 here. You can check. Now this is, I told you earlier, I showed in this in the previous presentation, Vincent Lugat used this approach. I am using the same approach. I am not changing anything. What I am doing, that is, I am adding some extra constraints. Now this constraint, you know, was mentioned by Vincent Lugat. So what I am doing, I am adding another constraint. See, if the glucose less than 105 and BMI is greater than equal to 40, so if it is greater than equal to 40 and less than equal to 104, 105, so you will get this region. Here you can address a lot of black points, and this value is equal to 0. The same way I am adding rule number 9 in 9, that is the insulin should be less than equal to 200. Then because when you are considering this diabetic patient, then you are measuring basically insulin. So if the insulin is less than 200, so the candidate is not a diabetic patient. And at the same time, in 10, I am considering if the blood pressure is less than 80, so rule 10, so the patient is not a diabetic. And the last rule, rule number 11, I am considering, that is if the pregnancy is less than 4 and pregnancy less not equal to 0, then in 11, that is the rule number 11 is equal to 0. Now, next, what I am doing, I am combining few features. I develop new features. Now I am combining the features. What I am doing, N0, column N0 is nothing but the BMI, all the column values multiplied by data frame corresponding column values are skin thickness. N8, rule number N8, that is DF pregnancies divided by data frame age value. Data frame glucose divided by data frame diabetics pedigree function. Data frame age multiplied by data frame diabetes pedigree functions. So this way you will get up to rule number 12, N12. Now this N15 also I am considering another rule, that is N0 should be less than equal to 1, less than 1035, 1034. So N15 is equal to 0. Now the next thing is what I am doing, I am just checking what is the final, data frame I am getting, because what I did basically, here you can check that is N0, N1, N0, N7, N9, N10, 11, N0, N8, N13, N12, N15, all the new columns you are having here. Because you are adding these new columns, and these new columns is basically maintaining certain rules. Okay. The next thing, so what you need to do, the next is you need to separate the output column. The output column is nothing but the outcome, that is the target column. Target column contains the variable 0 and 1. This variable 0 and 1 value is nothing but the two levels of a classification. So it is a binary classification. You just check you are getting the value only 0 and 1, so it is a discrete value, not the continuous value. So it is a classification problem. Next, what I am doing, I need to take this x, that is this independent variable, and when you are taking this independent variable, you need to remove the target column. The target column is nothing but this outcome. So you are removing it. So what you are doing, data frame dot drop, then the column name outcome and axis is equal to 1. Okay. Now from sklearn pre-processing, you are importing the label encoder. When you are importing the label encoder, what you are doing, that is the purpose of this label encoder is the 0 and 1. Okay. 0 and 1, these two values 0 and 1 is basically the values of the outcomes, but it's a label, it's not a numeric value. So what you need to do, you need to use an encoder, that is the label encoder, to convert it. So what I am doing, that is encoder is equal to from sklearn dot preprocessing import label encoder. Encoder is equal to label encoder, instantiate it. Then for column in y dot columns, for column in y dot columns, because y is a data frame, it has only one column, so outcome, what I am doing, y column is equal to encoder dot feed transform. You are transforming the value y dot column. So here in this line, what you are doing, you are using the label encoder to converting, that is 0 1, these values, because you may get confused, that is it's not a actual a numeric value. It is basically showing there is level 0 and level 1. So you are converting it, you are using this encoder. For instance, you can recall one hot encoding. You can use these pandas get dummy functions, and you can do it. So finally, what you are getting, that is y is this outcome. Okay, y outcome you are transferring to y, and you are taking all the columns n1, n2, n3, n4, n5, n6, n7, n9, n10, n10, and n11, and you are using the level encoder to transform this value. The next is, after the transformation is over, now you need to split the data set. That is X train, X test, Y train, Y test, train test split. So XY test size is 0.2, means you are taking 80% for training, and 20% for the testing, and random state is equal to 42. Now, after that, what you are doing? See, this is I am using because I have used the rule-based approach. I have, drawn the horizontal and vertical lines to get the small regions. And if I'm not wrong, this is the, fundamental concept of the non-parametric method. So I want to start with this non-parametric method or non-parametric approach. It is nothing but decision tree. So that's why I'm taking the decision tree, but I'm using an ensemble approach. It is known as the bagging. So what I'm doing, that is the bagging, is bagging classifier, decision tree classifier. I'm considering number of estimators is 500, maximum sample is 100, bootstrap is equal to true, n jobs equal to -1. It means, multiprocessing this, how many number of processors you have. It can use minus of one. That is, if you have three number of processors, it will use the two processors, so it will boost up the processing speed, and at the same time it will reduce the computational time. So random state is equal to 42. Out of bag score is equal to true. I think if you forget, that is one third of these, uh, you know, uh, data. When you are considering the data, one third of it is considered as out of OB out of bag score. So this is I'm considering out of bag score is equal to true. Then after that, what I am doing, bagging dot fit. I'm using the X train and Y train. Okay, X train and Y train, X train value and corresponding Y train value I'm taking. Now next is the confusion matrix, because it is a classification approach. So yeah, what you can do, you can measure this accuracy when you are using the confusion matrix. So always keep in mind this unavoidable error one, type 1 error and type 2 error. Type 1 error is more detrimental than type 2, so you keep in mind. So I'm using this confusion matrix bagging predict x test. So x test value, so what is the prediction you are getting, and y test, that is this actual value. Then I'm using this heat map, that is from the seaborne sb dot heat map confusion matrix. Annotations is true. See this annotation you will get. Format is 0.2g, and cmap is where it is. Then you plot the show. You just plot it. You will get this 9546. Okay, correctly classified, and it committed mistake 9 and 4. So what will be this accuracy? You can easily find out. That is 95 plus 46 divided by 95 plus 46 plus 9 plus 4. So you can get it. So instead of this confusion matrix, there is another approach you can get from this classification report. You can get it from this matrix. So you can check here, when I'm importing here, that is from escalon.matrix import confusion matrix classification report accuracy score. So now I will use this classification report, and I will show why classification report is, more meaningful than the confusion matrix. Now here you can check, that is the precision, recall, F1 score and support. So you are getting precision 0.96, recall 0.91, F1 score is 0.94, and support is 104 for corresponding class 0, corresponding class 1, precision 0.84, recall 0.92, F1 score 0.88, support 50, accuracy you are getting 0.92. So the fundamental concept, I think I have proved, that is when you are, using the rule-based approach and you are separating or splitting the feature space, drawing these horizontal and vertical lines, you are considering each and every region. Then if you use the decision tree, because decision tree is a non-parametric method, then you are expected to get higher accuracy. Now I am using the next approach. This is a very simple approach. It is known as voting classifier. So let us start with the voting classifier. What I'm doing in the voting classifier, I'm using, this is also an ensemble, I'm using the logistic regression, random forest, and support vector machine. Now, always keep in mind when you're selecting the classifiers, this thing is the if you find this your algorithms, are entirely different from each other, then the or accuracy of the ensemble approach is expected to be higher. So that's why I'm using the three different approaches: logistic, regression, random forest, and support vector machine. So what I'm doing, I'm considering Euler, I'm instantiating logistic regression. Maximum iterations I'm considering is a very high value is 10,000. Now random forest classifier, I'm instantiating an SV, that is support vector classifier, I'm instantiating. Then voting classifier estimators, I'm using the certain tuples, that is LR, means logistic regression corresponding LR, this logistic regression. RF stands for random forest, corresponding random forest. Here you have I have instantiated it earlier. Now SVC, that is support vector classifier, and this is the SV is a support vector classifier you have instantiated. Now the voting method is hard. So when you are using, in the voting method, there are two type of methods you will get: soft method and hard method. I'm using this hard method here. So voting.fit, X train and Y train. So you will get finally the confusion matrix. In the confusion matrix, as usual, I am considering confusion matrix within first bracket. The first argument I am considering voting.predict the X test. So what is the predicted value or Y hat value? A corresponding Y test, what is the actual value? And then you are using the SB heat map. You are just checking how much accuracy you are getting, and you are showing it plot.show. So you will get it. Now, finally, I'm using this classification report. So here, you can get it more clear picture. That is, accuracy is very poor comparing to the previous one. It is getting only 81% accuracy. Now, the next one is the Gaussian net base. Now, Gaussian net base, I'm instantiating GCF a Gaussian net base. Okay. Now, after that, what I am doing, gcf.feed, I'm passing this explain y trend value. Then I'm calculating the confusion matrix of this name. And then I'm showing that is the confusion matrix, how much you are getting. That is accuracy is 67 plus 46 divided by 67 plus 46 plus 9 plus 32. So you can get it accuracy. Now, if you use the classification underscore report directly, so y test the predicted value and gcf dot predict x test value, so you can get this accuracy is very poor is 0.73. Now, so here it is very clear when you are using rule-based approach, and if you are selecting an algorithm, this is a nothing but a non-parametric algorithm, so definitely accuracy will be higher. So here you will get an idea of how to select an algorithm, what approach you are using, and what algorithm you are selecting is very, very important. Now next is I'm using this support vector machine with the GridSearchCV. In the support vector machine, the GridSearchCV I'm using as because GridSearchCV, the purpose of the GridSearchCV to find out the optimum value of the hyperparameter. In every machine learning algorithms, you will get certain parameters, and their parameters value you have to select with the trial and error approach. Now, instead of using this trial and error approach, you can do it manually. It will take a lot of time. So another fast approach is you can consider the grid search CV. So in these presentations, I will show you, I will discuss about the grid search CV as well as the random search CV. So I'm considering a parameter grid is nothing but a dictionary. The C value I'm considering 0.1, 1, 10, 100, 1000. Gamma value I'm taking 1, 0.1, 0.01, 0.001, 0.001, etc. And Carnell value is RDA, radial basis functions that you are considering. So instantiate standard scalar because you need to transform the independent variable, so you are transforming it. So std, that is a standard scalar object dot fit transform, you are passing the x, that is the independent variable, so you will get the corresponding transform value, that is x1. What you are doing basically, you are normalizing it. Now after that you are splitting, that is x train comma x test, y train comma y test is equal to train test split x1 y test size is 0.2, that is 20% you are considering, random state 42. Now you are using the GridSearchCV where you are using this model, that is SDC classifier, passing the parameter grid, refit you are saying true, verbose means you need to check elaborately. Now grid.fit, you just pass x train and y train, and now you start computations. You will get large number of values, c values, gamma 1 and the kernel and the corresponding values, and you can check what score you are getting. Okay, so this is the purpose of the grid search CV. So it will check all the values that you are applying, means you are giving, and after that it will select the optimum value. Here you can check this optimum value. This is the input and the corresponding it will search, and after that it will populate this algorithm with this optimum value of what, c, gamma and kernel. Now what you need to do, you need to print classifications report, y test, grid predict, x test, but you are getting very poor result, that is a 0.75 accuracy. Now next is I'm using this random classifier, I'm using the GridSearchCV. Now random classifiers, that is n jobs, number of jobs is equal to -1, max features is equal to square root, number of estimators 100, out of OB score is true, parameter grid number of estimators 200, 700, and maximum features is auto square root log 2. So GridSearchCV, if you use this estimator is equal to random forest. Now parameter grid is equal to, you are considering parameter grid, and cross validations you are considering 5. So RFC dot fit x train and y train, if you pass, then if you print this classification report, you will get this accuracy, often accuracy is 0.8. Now in this next presentations I will discuss about the XGBoost classifier. Corresponding accuracy you will get 90. NGBoost classifier corresponding accuracy will be 89. Light GBM classifier, I will use, you know, random search CV for the light GBM, and you will get the corresponding accuracy is 91. AdaBoost classifier corresponding accuracy is 86. Then weighted average and stacking, and after that I will conclude. So this is all about the different approaches. So I am discussing about the 10 different approaches. Already I discussed bagging, voting classifier, support vector machine, grid search CV, random forest classifier, grid search CV. So in this next presentations, I will discuss about this XGBoost, latest algorithm, that is the NGBoost, Microsoft favorite Light GBM, AdaBoost, weighted average, and stacking. So thank you very much. If you have any question, you can ask me directly, or you can send your queries to my email ID. Thank you.